It's taking its sweet time. All right, so degrees to radians. It actually says convert DMS to radians, so some of them are already in like degree, like actual degrees, and some of them are in DMS, which that's the only ones I'm gonna do because you already know how to do the other kind. So it's actually going backwards a little bit, but 11.83 degrees. So this one is just in like a decimal form, so we don't have to do anything other than just convert. Like we don't have to change like minutes or anything like that. So this would just be times pi over 180.
How far out do you want us to go?
3.
0.206 radians.
Yep. But we need to make sure we put the RAD on there since it's not, doesn't have the pi to signal that that's what that is. If you get one like 16 where it gives it to you as 75 degrees, 30 minutes, we have to convert the minutes into a decimal before we can change it to radians. So what is our conversion for minutes?
Add over 60?
Yep, 30 over 60 for this one. So that's 1/2 or 0.5. So then we would take 75.5 degrees and then we would do it by pi over 180. All right, next thing, you've done this before. We did it back in Algebra 2, I guess, but arc length. But when we did it, we were finding arc length and area, and we were specifically doing, like, finding arc length. Like, now we're going to be finding potentially other pieces of it. So they might give you arc length, and they might give you theta, and you have to find like the radius, the R value, or they might give you arc length and the R value and you have to find theta. But do you remember what has to be the case with theta for arc length?
Has to be in radians.
Yep, has to be in radians. Did you miss that on a quiz last year? Is that why you remember that?
I don't know. I just
Oh.
pulled that
She
out
did
of
miss
nowhere.
that on a quiz.
I remember. I'm sure I did.
I think I remember her missing that on a quiz.
I probably did.
Yeah, you probably did.
5 or 6 times.
Sounds like Virginia.
So S equals R theta. Now in this notes set, there is a formula that they give you that has the pi over 180 in it. So they add a pi and they divide it by 180 so that you don't have to convert the theta before that. But I would just get used to converting before. I mean, that's the way we've always done it. I think the other formula is harder. So S equals R theta. So 26. They don't give us S. They give us R is 1 centimeter. And theta is 70 radians. So S equals 1 times 70. Man, it's a really tough one. So S equals 70 centimeters. And don't forget, units are essential on these ones. Um, 28. They give us that S is 2.5 centimeters. They don't give us r, so that's what we're going to be finding. And theta is pi over 4. No, pi over 3, sorry. Virginia, how are your pretty notes going?
Pretty good, actually.
Quite pretty.
I know. Hold on. Let me show you my favorite one.
I didn't know if you'd given up yet or not. You told me you
Not
didn't know how
yet.
long it would last.
Wow.
I know.
Wow.
Pretty good.
What is even that?
I don't
It's like
know.
4.4, 4.5
4.5
something.
Oh.
When I mess up, I get a little sad, but I'm still going strong.
Holding on.
Nice.
You need a
It
hug
was the
for
longest
that.
I've ever lasted.
So ask Riley.
I was like, is Josh about to give you a hug?
I mean, I would if you wanted one. I mean, I like hugs.
All right, so we normally start out with s equals r theta. So if we want to solve for r, we are going to have s divided by theta. So 2.5 divided by pi over 3, which would be the same as multiplying by the reciprocal. So that's going to end up being 2.5 times 3 divided by pi.
Two, 1, 3, 8, 7 centimeters.
S is equal to 4 inches. R is equal to 7 inches. And we're finding theta. Now, I'll tell you for their theta, they do not convert it to a decimal. If it gets to that point, they will leave them as a fraction for those. So s equals r theta, but we're solving for theta, so theta is equal to s over r, which is 4 over 7, and then they just put radians on it, and that's where they leave that. They do not convert it. All right, do y'all need to see one where we're converting the degrees to radians, or are we good with that?
Probably one.
One? Okay. So 32, we have S is the unknown value, R is 5 feet, and theta is 18 degrees. So you can either convert theta before, or we can use the modified formula that has the pi and the 180 in it. So which way would y'all prefer to do it?
Maybe try both. See how we feel about them.
The first one.
Whichever's easier.
Yeah, pretty much.
I mean, the one where it's already in the formula is less work, but they're equally the same difficulty, so I don't remember what the...
I don't know. Yeah, I was gonna say I don't know.
Maybe just do both.
Maybe the one will be.
I'll do the new one that you haven't done before, because you already know how to convert, and if you can convert, then you just plug it in like normal. So it's pi times r times theta over 180, because that way the degrees will cancel for theta. So we have pi times 5 times 18 divided by 180.
Is that what you got, Virginia?
Okay. Let's look at a couple of word problem type things. So just an example. Find the perimeter of a 60-degree slice of a large 14-inch pizza So now, a 14-inch pizza, that's talking about the diameter, so we need to make sure we pay attention to the fact that that means that the radius of that would be 7 inches. A slice of pepperoni pizza. Draw your favorite kind. Might throw some pineapples on there because I love pineapple on my pizza.
Just a cheese girl.
But you love pineapple?
I love pineapple.
We know
but,
you're
like,
a little cheesy sometimes, Virginia.
I usually just order cheese, but I like pineapple on pizza. I don't think it's bad.
Do you like pineapple in general?
Well, you would know,
Yes.
Riley.
Grilled pineapple is so good.
That is good. I will say.
I like pineapple. It's tasty.
Alright, so we need to find, okay, we're trying to find the perimeter of the slice. Okay, now I drew the picture because we need to understand that the perimeter is going to be this side, and this arc here. Okay, so we already know this two sides because that's this 7-inch radius part. I need to find the arc length of it. So S is equal to R theta. Now theta is 60 degrees. We have R. But theta is in degrees, so I'm going to use that modified formula like we did in the last one. So S is equal to pi times 7 times 60 divided by 180. And you can just do one decimal place on this one.
7.3 inches.
So 7.3 inches. So then a lot of people are tempted to stop here, but this is technically just this arc length perimeter. So we have to add everything up. So 7 plus 7 plus 7.3 is the perimeter. So that's going to be 21.3 inches is the perimeter of that slice of pizza. Which makes it sound way bigger than it probably actually is.
Yeah.
All right. So now one from the book. They have a few short word problems and then some longer ones. So one of the short ones, number 36, says a 100-degree arc of a circle has a length of 7 centimeters. To the nearest centimeter, what is the radius of the circle? So what pieces of information did they give us?
They gave us the arc length and theta.
They gave us the arc length and theta. So S is equal to 7 centimeters. Theta is 100 degrees. And I'm trying to find the radius. So S is equal to pi times r times theta divided by 180. But I'm trying to find r. So I'm going to multiply by 180 and then divide by pi and divide by theta. So r is going to be equal to 180 times s divided by pi divided by theta. Now, if you wanted to just plug numbers in instead of solving for r first, you could also do that. It's totally fine. So 180 times 7 divided by pi times 100. So I can give you a visual of what we're looking at here. Anyone?
You guys gonna say anything? I'm leaving this one for you.
39 point.
Okay, what? How? Riley, it's your turn now.
4.01?
It's rounded to the nearest centimeter.
Oh. 4.
There we go.
4 centimeters. Not sure what you typed in, Virginia.
Did you not have parentheses around pi times 100?
Oh, no.
So you divided it by pi and then multiplied it by 100
Slide.
instead of dividing it by 100 pi.
Okay, I got it. Yes.
You got it now.
Yep. I knew it didn't sound right. That's why I didn't know it
Sounded too big of a number.
I know.
Okay.
Silly Virginia.
Let's see. 45. A longer word problem.
Yay.
Kathy races. I'm going to take a few words out here and there just because, whatever. On a bike with 13-inch radius wheels. When she is traveling at a speed of 44 feet per second, how many revolutions per minute are her wheels making?
That's a lot of stuff we'll have to do with this one. A lot of conversions.
So we have 13-inch radius wheels. She's traveling at a speed of 44 feet per second. And we're ultimately trying to find out how many revolutions per minute, her wheels are making. So we see that we don't have units that align, so we need to make sure we pay attention to that when we set this up. A few things that you probably don't know are that 1 radian is 1 radius of arc length. And 2 pi radians is 1 revolution. So that's going to be a conversion factor that we need to have. Now, there's one other thing that I didn't mention. So I talked about the minutes and seconds, but what else do you notice?
Inches and feet.
Inches and feet. So we're going to need to make a conversion for that as well. So I would start out with this problem going ahead and converting that 13 inches into feet, just because I'm going to need those conversions, and I really don't want to convert 44 feet per second into inches. It makes more sense to convert this smaller one that's just inches by itself to feet. So 13 inches, and then the conversion of 1 foot is 12 inches. And that should come out to 1.08 feet. And that's going to be our R value, our radius. So now we're going to set up a conversion just like you would do in chemistry or any of the classes that you have to do conversions in. All right, so the first one I would do is 44 feet per second. Makes the most sense to start with that. Now, I said 1 radius is 1 radian. So this is my radius here. So 1.08 feet in 1 radian. But I also told you that 2 pi radians is 1 revolution. So 1 revolution is 2 pi radians. And lastly, I have stuff in seconds, so I need to get that minutes conversion. So since seconds are on the bottom down here, I'm going to put 60 seconds in 1 minute up here. So then I'm going to verify that I got all my units taken care of before I actually start plugging stuff in. So feet cancel, seconds cancel, radians cancel. So I'm left with revolutions in a minute, and I'm ultimately trying to get to revolutions per minute. So now you can multiply and divide.
What do you want us to round it out to?
Let's just do 1 decimal place. It doesn't specify.
Virginia, do you want to read it?
I'm too scared. I got a really big number.
You can do it, Virginia.
1.
What?
Are you kidding? I can't.
Did you multiply 44 times 60 and then divide by 1.08 and divide by 2 pi?
How did you get 1?
I don't know.
You got just 1?
No.
389.
No, that was
Yeah.
1. You know what?
We should let Virginia keep on trying until she finally gets it right. I thought you grew out of this, Virginia, good.
Oh, now I got it. Why did I always get it the second time?
Maybe you should always just do it twice just to be
Yeah.
safe.
And then just go with the second answer.
Like intuition, just.
Go with the one that.
Usually we tell people to go with their first answer, but maybe you should go with your second.
Yeah.
Probably for the best.
If it seems suspicious, try it again.
They always do.
In math, anyways.
Yeah, I got 1,005. No, 15,000
Wow.
the first time.
Oh.
We had a big number.
Oh, I thought you were just saying you
no,
got
I was
one.
trying to make sure I got the first digit right, but then based
No.
on everyone's reaction, I was like, I'm
No,
not
you-
gonna know this. That's horrible.
At least we found out what you got.
All right. Your problems are gonna be. I didn't give you any yesterday, right?
No.
3, 7, 15, 21, 25, 27, 29, 31. Did that include a word problem? Hold on. You don't. No, that's fine. $35, and then 47 is similar to the one I just did with you, but it's a radial arm saw, so it's still got the concept of it being like a wheel, but it wants to know how many teeth are crossing the cutting surface each second. So once you get down to what you're doing, then you're going to have to take that and multiply that by the number of teeth. And I'm going to tell you it's a really big number.
Oh, so
So your
Virginia-
15,000 might
Maybe
work.
I have more of a
Virginia,
chance.
don't be scared.
It's much closer to that number than. So, anyways, just to let you know, and we can obviously go over whatever. My plan is to start 4.2 on Tuesday. Hopefully, we'll get through 4.2, 4.3 by next Friday, and then we'll probably quiz after that. Is the goal. We'll have a unit circle quiz in there somewhere too, maybe next Friday. Probably do the unit circle on Tuesday. But if you want to, I don't have copies of it, but I have a unit circle laying around here somewhere. I think it's in the purple box if y'all want to take a picture of it, just so you have it for the moment, and then I'll get you copies for Tuesday. The only thing that one doesn't have are the tangents on the X and Y axis, because I started including those when I realized they were needed after I'd already made those, so that's the only thing that's not on there.